Dr. Suman Rawal. I am going to present geological investigation and its use for the civil engineers. First, we will try to understand what are the geological investigation. For the construction of any large structures like dam, tunnel, airport, and road, even for the building, we need proper geological investigation. So, engineers should have the fullest knowledge of the understrata. Without proper investigation, project not only involves the considerable high cost, but their stability also might be in question. The main objective of the geological investigations are: first is the lithology of the area. As you understand, lithology means study of rock, what type of rocks are present in the area. Second is the geological structures of the area. Geological structures like what are the status of fold, faults and joints in the area. Third is the condition of groundwater, what type of groundwater table is present there, whether it is above the ground or it is under the ground. I mean to say what are the groundwater condition over there. And third, and the very significant thing is that the seismicity of the area. Seismicity of the area means what are the condition of the seismicity there or the earthquake over there, whether the area is experience any large structure in near future or not. If any seismicity is there, what is the magnitude of this seismicity? Geological investigation are of two types. First is surface investigation, and second is subsurface investigation. Now we will talk about first surface investigation. Surface investigation, it includes first the preparation of geological map as we drawn in the practical session, that is the cross section of the area with the help of the already map prepared by the Geological Survey of India and the Survey of the India. This will give the idea about what is the elevation of the area, what is the topography of the area. Second is the aerial survey. Nowadays, this aerial survey has gained so much of significance because this is very easy and it takes very less time compared to the conventional geological map methods. It includes the satellite imageries and aerial photographs. Satellite imageries are of very significant. These are clicked by the many satellite waves which are working continuously in our atmosphere. This gives, if the satellite imageries correctly interpreted, this gives a very important information about the ground data. Even that can give us the indication about the subsurface structures also. Now we will discuss about the hydrological survey. Hydrological survey or the groundwater condition. In this we discuss about the drainage pattern. What is the drainage pattern of the area? Location of spring in the area, of spring, or what we can say, that is the waterfall in the area. Location of well, And another important, what is the precipitation and evaporation of the area. After the surface investigation, subsurface investigation is also important because it gives the details what is under the subsurface or which is not exposed to us. This subsurface investigation it is also having two methods. First is direct method and second is indirect method. First direct method includes trial trench, trial pits and core logs, which is sometimes also known as borehole data. In the indirect method, the main two methods are the electric conductivity method and seismic methods. Electric conductivity method is mainly useful for the rocks or for the metal which are the good conductor or are the bad conductor of the electricity. In seismic reflection methods is used for the when our rocks or our structure or our ore body have the very high depth. This method, seismic reflection method, is mainly used in the oil exploration, while this conductivity method can be used to understand the subsurface structures and also for the determination of the ore body which are the good conductor of the electricity or to locate the groundwater table in the subsurface condition. Now the most important direct method is the borehole data or the core log. Now I am going to discuss about the borehole data. A borehole into the surface of the earth is drilled up to the required depth. Means we will predetermine the depth. Using the suitable techniques, soil and rock samples are obtained from the ground below. As the drilling progresses, the observed samples are summarized in the form of a chart which is commonly known as the core log. When a core log from a few locations from the same area is studied, collected and interpreted it properly, very important structures, features of the rock like depth and strike, repetition or the omission of the strata and thickness of the each layer can be calculated very easily. If we will drill inside the earth, we may get one such type of core logs. We have the predetermined depth. That means every machine has some capacity or it can excavate up to the 3 meters or 1.5 meters or 2 meters or so on. So we may get a core of log which looks like this, like it may be clay soil, then second portion may be sandy soil and then it may be a sandstone which is friable sandstone. It is not very sound enough, friable sandstone. Then I may have limestone and then again limestone which which is having the appropriate amount of quartz, that is called as sandy limestone. This entire arrangement of the rock which we obtain after the drilling, it will be a cylindrical mass of the rock which we make it after the drilling into the rock. This is known as core rock. Now on the basis of this core rock, we can calculate the value of RQD, which is very significant for the any type of construction. It gives the detail about the what type of rocks is exposed in the subsurface condition, whether these rocks are suitable for a particular type of construction or not. This will give you the what is the joint frequency index, means the what is the frequency of joints as we go deeper inside the earth. One point I want to say over here that as we go deeper inside the earth, the joints and all the openings, they naturally die out. Now this RQD is rock quality designation. This rock quality designation can be calculated by the summation of all the core pieces which are greater than 10 centimeter length of core, which is greater than 10 centimeter, and divided by total run multiplied by 100. This value we will get in the percentage. If this value comes around 2 to 25, then I can say my rock is very poor, means that is not suitable for any type of construction. If this value comes between 25 to 50%, then my rocks are poor. If this value is between 50 to 75%, then rock quality is fair. And if it is more than 75 to 90, that is very good. Means this is suitable for maximum type of construction. And if it is more than 90, then it is excellent. Here we have one core sample. Here we can identify about the natural joints and mechanical joints. Natural joints are those joints which is naturally present in the rock. In the case of sedimentary rocks, this may be the bedding plane or any other divisional planes like we can see here. These are the natural joints. Apart from this natural joint, if I can see carefully over here, I can see some curved surface which was not actually present in the rock, but due to the faulty drilling, this core breaks down into the two pieces. So we will not consider it as a natural joint. We will consider as the mechanical joint. Now question arises how we can differentiate between the natural joints and mechanical joint. If we will see here carefully, we can see a smooth surface over here because it was the inherent to the rock, but this was developed during the process of core drilling. Here also I can see this entire core, which was a sound core, break down into the three pieces. But I will not consider it as a natural joint. I will consider it as a mechanical joint. I can see it can be closely fitted together, but I will see over here it will be considered as natural joint. I can see the smooth surface over here, very smooth surface. But if I will compare this surface over this small surface, this is because of the faulty drilling. We will have the sharp edges over here, and compared to here, I will get this smooth surface. Again, this is a type of mechanical joint, which is because of the faulty drilling. Now I have a question over here. We have to solve it. In this question, we have to calculate RQD, core loss and core recovery. Now to calculate the RQD, I will take the summation of all the joints which is having the length more than 10 centimeter. So if I will see this joint number 1, it is having the length of 18 centimeter. I will consider it in the RQD. Second joint, it is having the length of 9 centimeter. I will not consider it. Another joint which is having the length of 11 centimeter, it will be considerable. Then plus 12 centimeter. Now coming to this point, if I will draw it, it will be like this, 18 centimeter, because it is having the natural joint. It will have the smooth edge, smooth base. Then 9 centimeter, it is 18 centimeter. Then it is 9 centimeter, again natural. Then 11 centimeter, again natural. Then 12, again natural. Then 5 centimeter, which is having a mechanical joint. That means it breaks down because of the faulty drilling, not because of the inherent defect in the rock. It is 5 centimeter, it is 7 centimeter. So now instead of taking it as a different part, I will consider it as a 1. So it will become 12 centimeter. Now again it is considerable over here. I can write here 5 plus 7. Then 30 centimeter natural. It is also considerable. Then 8 centimeter. It is considerable. 8 centimeter. I will not consider it. Then 20 centimeter having the natural base. 20 centimeter, I will consider this. Then 25 centimeter, considerable. Then 5 centimeter, non-considerable. Then 2 centimeter with mechanical base. Then 15 centimeter with mechanical base. Again it will be like this. Then 10 centimeter with natural. We have to account it from 2m, 15m and 10n. We have to start counting unless we will get the natural joint at the base. Now I will consider all this part as 2 centimeter, 15 and 10 together. That means 27 centimeter. So it is also considerable. Then 10 centimeter, then 6 centimeter. 6 natural but not considerable, 8 natural but not considerable, 4 natural, not considerable. Now this is plus 30, plus 20, plus 25, then 27. Now in question paper, it will be already given, or in the question it is already given that the total run is of 2 meters, means 200 centimeter. It will be divided by 200 and multiplied by 100. This will be my value of RQD. If I will calculate it, then it will be 18 plus 11 plus 12 plus 12 plus 30 plus 20 plus 25 plus 27 divided by 200 multiplied by 100. So my value comes like 77.5%. If I remember the previous one, when this value is between 75 to 90%, then the quality of rock is very good. Now other task in this is to calculate the core loss. Core loss is the summation of all the core pieces irrespective of their length minus total run. All core pieces minus, I'm repeating here, that is total run minus all core pieces irrespective of their length. So all this value 18, 9, 11, 12, 5, 7, 30, 25, 5, 2, all this will be considerable, and we may get the value which can be around 30%. If we have the loose sedimentary rock, then definitely the value of core loss will be more compared to the igneous rock, which are very compact and hard. Now I have to calculate core recovery. This core recovery is total length of core pieces irrespective of their size divided by run 200 meter multiplied by 100. We'll try to get this value, that is 18. It is 195. So my core loss is of 5 centimeter, and it will be 195 divided by 200 multiplied by 100. It will be here my core recovery is 97.5%, which is the indicator of a good rock type for any type of construction. Okay, thank you.